Hi, in today's video, we'll have a look at the situations where you might prefer to use the mean, the median, or the mode. So let's say that we have the following data set. So we have 1, 1, 3, 4, 5, 7, 15. And let's say that this represents the number of people living in your household, which means the number of people living in your house. So we have a couple of households where you only have one individual, so only one person living in that house. In another house, you have 3 people, 4 people. It goes up all the way up to 15. Now, with the mean, the median, and the mode, we have 3 different ways of calculating the central tendency for that distribution. So if we look at the mode, we'd say, well, the mode is the most frequent value. So in this case, that would be 1, because 1 appears twice in the data set, and no other value appears more than once. Now, the median would be the middle value. So we just need to have a look, and we can see that given that it's odd, the median value is going to be 4. And for the mean, we would have to calculate it, and that would be 1 plus 1 plus 3 plus 4 plus 5 plus 7 plus 15 divided by 7, which is equal to 5.14 something. Okay, so as we can see, the results are quite different between those 3 measures of central tendency, and they tell us something different. So it might be useful to know that actually the most frequent configuration is just having one person in a household, because that might influence the types of houses you build in your area. Now, the median tells you something a little bit different. It tells you that 50% of the population lives in houses that has 4 or fewer people in them, and conversely, 4 or more people in them. And that also can be useful to know for policy measures. And the mean just tells us the average number of people per house. And so in this case, this is 5.14. So this measure uses all the values in our data set. Okay, as we can see, they all appear in the calculation of the mean, whereas that's not the case for the median and the mode. So in which circumstances could the mean actually not be that helpful? Well, let's think about the same data set, but now I will imagine that there's a clerical error, and so someone made a mistake, and instead of 15, put 1500. Okay. So very often data sets are compiled by humans, and humans are prone to mistakes. So it is absolutely crucial that you always check whether the data set that you're working with actually makes sense. And you will very often find that there are mistakes, exactly these types of mistakes. So here, someone put 1500, which is clearly a mistake. And we can see here that the calculation of the mean would not make sense, because when I calculate the mean, like before, I will get a value that is way too large, and that is not meaningful because it's affected so much by that 1500. In this case, I'll get something like 217, etc., which clearly is meaningless. So remember that when you have values that are wrong, and especially that are, for example, in this case, very, very large, the mean will not be particularly meaningful. So there's an obvious solution that you may have already thought of, which is, well, if this was a mistake in the first stage of your data cleaning, I can just remove it. And then I can calculate the mean as before. And there, the mean would become meaningful. Okay. But one thing to realize is that there are cases where those extreme values actually do make sense. So let's say we have another data set, which looks like this. So we have 30,000, 40,000, 50,000, 55,000, and we have a million. And let's say this represents incomes of different people in your country. Now, we can clearly see that this is an extreme value compared to all of the other values in our data set, but doesn't mean that this value is wrong per se. It could very well be the case that one person in the country is extremely rich compared to the rest of the population. So in that case, that value is actually meaningful, and it's not as easy as before to just remove it. Okay, but here again, if we calculate the mean, it will be affected by this extreme value, even though this extreme value is correct. Okay, so in this case, removing it might not be the solution, but we could calculate instead the median, because the median, which would be that value, is not affected by the actual values of any of the other observations. So the median is not affected by outliers. And actually, you'll see in national statistics, whenever we look at income, we always tend to focus on median income rather than the mean income, especially exactly for that reason, because you have those high values that skew your distribution, and it's more insightful to just look at the median. So remember that whenever you have outliers, you first need to think whether that outlier is a mistake or whether it's a genuine observation. If it's a mistake, you can obviously take it out, because that should always be the first step in any data analysis that you carry out. But if it's a genuine observation that is meaningful, then you might want to switch the measure of central tendency that you use from the mean to the median, because the median is not affected by outliers. So that's it for today's video. In the next video, we'll have a look at measures of dispersions.